Good evening, everyone. Welcome to Plutus IAS. Today, we are going to discuss a very prominent and important topic of geography optional, which is cyclones. And in cyclones, what I'm going to particularly discuss is the temperate cyclones. Now, talking about it, first we need to understand what are actually these, right? These are the disturbances, right? They fall under the disturbances part. And under disturbances, you have the two categories. One is your cyclones, then you have thunderstorm. So these are some of the air disturbances that we have. Now cyclones are further divided into the two parts, which is the tropical and temperate. Tropical and temperate. So today I'll be discussing about only temperate. I'll be giving you the notes and dictation of the temperate, and in the next class we will cover the tropical cyclones. Now temperate cyclones are also known as your extratropical cyclones. And why they are known like that? Understand, these cyclones are developing in the mid latitude, means 35 degree, 65 degree, they are building over there. And what is the main reason why the cyclones are being formed? Particularly temperate, that is fronts. Now for the people who have not done the fronts, they cannot understand the temperate cyclones. In order to understand the temperate cyclones, you need to know the fronts first, right? So my lecture is only going to be successful only when you understand what are fronts. All right. So because of this, I have to start the lecture with the fronts first, and then I'll come to the temperate cyclones. I'll not go in detail into the fronts. I'll just discuss the part which is very necessary for the temperate cyclones, right? So if you have done the fronts, it basically means when two contrasting air masses meets. When I say word contrasting, it means either cold or warm, right? Either cold air mass or warm air mass. And why I'm using the word air mass? Because air mass denotes the uniformity. Uniformity in the sense of temperature, horizontal distribution, of pressure and humidity. Everything has to be same in order to call it as air mass. Now, when two air masses, which is the cold one and the warm one, are meeting together, it creates contrasting air masses. And when these two contrasting air masses will build up in an area, for example, it is building up in this area, and when these contrasting air masses are building up in this area, it will generate the possibility of formation of fronts. It is not necessary when the two contrasting air masses are there, it is bound to create the fronts. But yes, your two contrasting air masses should be there. That is one of the factors that should be there definitely in order to create the fronts, right? Now coming to the distribution part first. Look at this map. So how the fronts will be formed? The fronts are going to be formed because the warm air masses which are present in the tropical regions, this region, and this is your colder air mass. This is one of the examples that I'm showing. These contrasting air masses will meet. Right? This is one of the example I'm showing, by the way. There are different types of fronts which are there, and we have already discussed it in the class. That part has already been done. But since the students who are joining in for the first time and they have no clue about how the temperates are being formed, how the front, because to understand the temperate cyclone, you need to know about the fronts first, right? And just to make it very simpler for you, it's just that when two air masses, cold and warm, that's it, they are meeting. How many types are there and what are its detail? You don't need to get into that part. That is a separate section altogether. But for now, to understand this particular topic, you just need to know when cold and air masses meet, it forms the fronts, right? All right. Now, how the temperate cyclones are being formed? As I mentioned, temperate cyclones are going to form in mid latitudes. And apart from that, these cyclones are going to form, so they are very pronounced in the area of northern hemisphere. They are quite pronounced in the area of northern hemisphere. Reason being, in the northern hemisphere, you have land and water bodies distribution, right? Both land and water bodies distribution is there in the northern hemisphere, while in the southern hemisphere you're only having the water, the amount of the water bodies present is more. The percentage of land is less in the southern hemisphere. That's why the temperate cyclones are more pronounced, although they will form in both the hemisphere. In the northern hemisphere also and in the southern hemisphere also. They will be formed in the both hemispheres, but particularly they are more pronounced in the northern hemisphere because the percentage of the land area is more in northern hemisphere. Right? All right. Now, the second thing is that whether the temperate cyclones are only formed because of the fronts or there is any other reason also. So just to give you a little difference of two cyclones which I have discussed initially, the tropical and the another one, temperate cyclones. Temperate cyclones are completely formed because of the fronts. There is no other contribution. There is no convection currents. For example, there is no low pressure area which I was discussing earlier. I mean, I need to say that temperate cyclones are formed on both land also and water bodies also. They are formed on both. Unlike your tropical cyclones, which are formed on the water bodies, right? So they are formed on both. Are they forming 365 days? Are they forming in every season? Yes. They are formed in the winter, summers as well. But the point is, again, they are more pronounced. The intensity is more in the winter season. Reason being because the contrasting air masses is again more in the winter season as compared to summers. Right? So this is the initial detailing of the temperate cyclones, how you have to understand the temperate cyclones and why are they important. Yes, Soumya, Ishan, Mumni, everyone. Any doubts so far? This is an extremely important topic, and since this is a topic which is going to get, I mean, you are going to get it in the prelims. The question can be asked in the mains as well, in the prelims as well. So This is extremely important to understand the concepts of temperate and tropical cyclones at this point of time. All right, good. So just let's talk about the definition of the temperate cyclones. Write down the depression or the low pressure centers. The depression or the low pressure centers associated with frontogenesis. Associated with frontogenesis. Frontogenesis is simply the formation of fronts. Formation of fronts. Write down. The depression or the low pressure centers associated with frontogenesis generating in the regions of 35 to 65 degree, generating in the regions of 35 to 65 degrees north-south latitudes. North-south latitudes are known as extratropical cyclones, or temperate cyclones. Next line. They are also known as wave cyclones. Why they are known as wave cyclones, I'll explain in the later part of the section. But right now you need to just understand the definition of the temperate cyclones, why are they formed like this, and then we'll get into the detailing of it. Write down. They are known as wave cyclones. Next, cold and warm fronts. They are formed at the place where cold and warm fronts meet. Where cold and warm fronts meets. All right. Getting into the detail of the temperate cyclones. See, look here. Nobody is going to write right now because this is important. Please look at the board. Suppose this is a cold front and this is a warm front. Now the first stage of the formation of the temperate cyclones will be when nothing is happening here. It's just that cold front is getting near to the warm fronts. That's it. When the cold front is getting near to the warm front, there is nothing happening here. And there's a kind of a front which we call it as a stationary front. It is that type. But you don't have to get into that. Again, I'm saying this is the position. The first position is it's just that cold front is here and the warm front is here. Right? Then gradually what will happen? The warm will try to go into the spaces of the cold, and cold will try to get in the spaces of the warm. Right? And gradually it will happen. It will not happen all of a sudden. It will take its time. The second position will be now the warm front is going to get positioned like this. Reason being, what is the reason here? See, this particular part is pushing like this and this part is coming like this. So can I say there will be a formation of enclosed circles? Can I say there will be the formation of the closed circles? This is a warm front, right? What is happening? Because you know that the air in the warm front is going to be what? A little unstable. Because warmness is associated with ascending of the air. And as the air tries to ascend, it will go into this space, right? The moment it will go into the space and it is descending, the cold part, it is descending this side. Then what will happen? It will create a calm region. So this is going up and this is going down. Can it create a closed circles like this? Can it create a closed circles like this, right? Can I associate this area as a cold front and this as a warm front? Since warm front is associated with the low pressure region, this low pressure area will be trapped in between. And there is going to be the formation of V shape, inverted V, which will be formed here, right? And this cold front, which has been formed outside, is the area of high pressure, right? Therefore, we call temperate cyclones as not the type associated with, this is not a type which is associated with closed isobars. These are open, as you can see. It is open, it is elongated. Okay. Now let me know, all the online students and offline, are you able to get it? Bataiye. Anything which you are not getting in this, I can again draw and tell you. Yes. Mumni, Soumya, all of you. Good. Very good. Right? So, understand this point that when I'm talking about the warm and the cold front, again I'm repeating for the students who have not got it, because this is a little tricky part here, that you have to understand the cold and the warm front at the same point of time. You have to understand the positioning of the warm front as well and the cold front as well. So it will become difficult to analyze. So understand, if this is a warm front and this is a cold front, it tends to ascend as this part of the warm front is unstable, right? Because see, the first position will be same. आपका जो पहला position है वो static होगा. That means they will be just standing against each other. Only cold front and warm front will be placed like that. There is nothing much is happening at this point of time. That is just the starting of the formation. Nothing is happening here. In the second stage, in the third stage, there would be some kind of development which is going to be there in the temperate cyclones. And when I talk about these temperate cyclones, the formation of the cold front and the warm fronts are going to happen. At one side, there will be the cold fronts, at the other side, there will be warm front. This warm front will go into this part basically. Ideally, this would have been the shape which I intentionally skipped. Cold fronts shown by triangle and warm shown by half circles. Right? Now, can I say in the third stage, when there is more development going on, it would look like this. Now, my this region, which is spread so much, it has decreased. Now it has come, now this has gone up, this has come down. This is a low pressure area. Right? And it is encircling around it. Now, low pressure is trapped in between and we call it as inverted V. This is known as inverted. It is trapped, it is known as inverted V. It looks like a valley shape also, it is closed also, but it is not entirely closed like tropical cyclones. Like tropical cyclones are exactly closed isobars, but this one is not exactly closed. This is an elongated shape which you will have. Okay. So it will have an elongated shape. It is going to have an inverted V. There is going to be the formation of the cold fronts here. And it is also important to note that how these fronts are creating different kind of seasons. I mean, how they are impacting the weather conditions of different parts of the world. If I talk about India, these western disturbances, when they come in winters, they bring what disturbances in India and other parts of the world. And these are not the only type of the western disturbance. This western disturbance is not only the type that we are having the temperate cyclones. There are other types also which are available, but we are not discussing the types. I'm just giving you some of the examples which are present. We have done western disturbances and everyone is aware about that, right? So you can consider the western disturbance as a part of the temperate cyclone. Is one of the part, correct? Okay, write down. Write about shape and size. Write down about the shape and size of the temperate cyclones. देखिए. In temperate cyclones, isobars are not closed. In temperate cyclones, isobars are not closed. In temperate cyclones, isobars are not closed, but they take the shape of but, and also you can support whatever you're writing with the diagram. Whatever you're writing, please support it with the diagram. I've told you ample amount of times that if you're not drawing the diagrams in geography optional, then you are intentionally reducing your marks. If there's a scope to draw the diagram in a question, please draw it. Please support your answer by drawing the diagram. Write down. In temperate cyclones, isobars are not closed, but they take the shape of inverted V. Therefore, they are also known as, therefore, they are also known as V-shaped depressions. And hence, they are also known as V-shaped depressions. Full stop. The longitudinal axis of this depression, the longitudinal axis of this depression shows that they are wider at the north part. If you see closely here, the north part is more widened as compared to the lower part, right? If you see this part, it is contracting. This one is contracting, again contracting. But as you move upwards, how it is behaving? It is widening up. So the upper part is going to be more widened up, right? Write down. The diameter of the cyclones may vary from 160, put a hyphen, to 3000 kilometer. This is the diagram they're talking about. If the cyclone is supposed to be not so affecting a large area, then definitely it will have the diameter less, between the range of 300 to 500 or maybe 700. But if we are talking about the cyclone which has impacted the larger area, definitely the diameter is going to be greater. Write down. The diameter of the cyclone may vary from 160 kilometer to 3000 kilometers. To 3000 kilometers. Write down next. They generally cover an area of about 1.6 million square kilometer. They generally cover the area of 1.6 million square kilometer. And the vertical extent is about, and the vertical extent is about 10 to 12 kilometer. The vertical extent is about 10 to 12 kilometers. The vertical extent is about 10 to 12 kilometers. This is the vertical extent. This is the horizontal. Right? Horizontal extent we have discussed in terms of diameter. Vertical extent is this one. Right? This is the description of the shape of the cyclones that we have discussed just now. Write down. Trough in temperate. There is a term called trough. Right? The trough formation which is happening here. And please understand the area of this trough is not going to be same every time. The moment it is going to further proceed in the maturity of its formation, it is going to get smaller and smaller, right? Again, what I have shown to you, it was spreading like this, right? And again, in the next stage, it would get reduced and again get reduced, and therefore the shape changes. Write down. Trough in temperate, ब्रैकेट में लिखेंगे mid latitudes. Trough in temperate, ब्रैकेट में लिखेंगे mid latitudes. Trough in temperate, ब्रैकेट में लिखेंगे mid latitudes region is an elongated area of relatively low atmospheric pressure. Is elongated area of relatively low atmospheric pressure. Low atmospheric pressure. Comma, representing a dip or valley in the pressure field. Representing a dip or a valley, representing a dip or valley in the pressure field. Representing a dip or valley in the pressure field. Write down next. When these isobars take an elongated shape, when these isobars take elongated shape, the pressure system is called trough. The pressure system is called trough. Now understand the formation again. Look at these points. Now the formation is happening here, and how it will move? It will move from west to east. The direction is going to be from west to east. When it's going to move like this, we call it as western disturbances. It is known as west, and most of the time it will move from west to east only. Whenever you will see it, whenever you will analyze it, it is also a factor. There are some exceptions which are there. Obviously, I'm not going to discuss about those exceptions, but most of the time it is going to blow from west to east, and these are known as the western disturbances in India. And we also call this movement as eastward. We call this movement as eastward, moving like this. Okay. Now, talking about the characteristics of the temperate cyclones, how is the characteristics? Temperate cyclones unlike tropical cyclones which bring a lot of thunderstorm etc., they do bring the rainfall, rain precipitation is going to be there because there would be the formation of the cumulonimbus clouds. But the tropical cyclones are forming, for example, major havoc, major destruction, but temperate cyclones are not like that. For example, in summers, they are going to be having normal conditions, but in winters, it will become more pronounced. And the moment it becomes more pronounced, there are different types of temperate cyclones we will have, right? Now write down next, write down about the characteristics for the, write down about the characteristics. Temperate cyclones formation. Write about temperate cyclone formation. Quickly. Temperate cyclones exhibits wide variety of characteristics. Temperate cyclones exhibits wide variety of characteristics such as, write down, they are predominantly, write down, they are predominantly formed at the region of fronts. They are predominantly formed at the regions of fronts. After coming into the contacts of, after coming into the contacts of two different air masses, which I have told you, one is cold air mass and other one is warm air mass. One is your cold air mass, another one is your warm air mass. Again, write down, this type of cyclone is more pronounced in, this type of cyclones are most pronounced in the northern hemisphere. They are more pronounced in northern hemisphere due to the more area of land, due to the more area of land in the northern hemisphere, and less area of the land in the southern hemisphere, and hence they are less pronounced in the southern hemisphere due to less area of land. Or you can write in another way that there is much larger area of the water bodies which is present in the southern hemisphere, right? Again, I am repeating the point. In the northern hemisphere, the temperate cyclones are pronounced. Reason being because the area of the land which is there is much more as compared to the southern hemisphere. Write down next. Velocity. Write down about the velocity of the, write about the velocity of the cyclones. What is the velocity of the cyclone? Write down. Temperate cyclones are formed over large areas. Temperate cyclones are formed over the large areas. The development of the low pressure systems is not quite intense. The development of the low pressure system is not quite intense, and hence the isobars are relatively wide apart. The isobars are relatively wide apart, and velocity varies from, 30 to 40 kilometer per hour, and velocity varies from 30 to 40 kilometer per hour. Now look at this point. When the formation of fronts is happening, in the initial stage, and this is the final stage, now how your temperate cyclones look like. It is like a elongated isobar which is formed here, it is open and it is formed like this. Now, when these kind of isobars will be formed, now this area which is your high pressure region and this is your low pressure. Now, the difference, and the difference we also call it as the pressure gradient. This is a pressure only. Your cold front is associated with high pressure and your warm front is associated with the low pressure. When your cold front is associated with the high pressure and the warm front is associated with the low pressure, the difference that they are having between the high pressure and the low pressure is not much. And when the difference is not much, the velocity is automatically going to get reduced, right? Therefore, if you see, the velocity of this is not much. Why they are only having the 40 to 50 kilometer per hour, that is max in some areas on an average, is because the velocity depends upon the difference between high pressure and low pressure. Difference between high pressure and low pressure. And when the difference is more, the velocity will automatically increase. When the difference is more, velocity is automatically increased. And when the difference is less, the velocity is going to be less, right? So more the pressure gradient, higher is going to be the velocity. Less the pressure gradient, less is going to be the velocity, right? Write down next. Write down frequency. Frequency. Since the temperate cyclones are formed, since the temperate cyclones are formed, is it necessary that the temperate cyclone should be formed particularly in particular season or particular area? No. Reason, because the temperate cyclones, the condition required for the formation of the temperate cyclones is not like that of the tropical, wherein you need the particular condition, like you need to have such a particular season to create the formation of temperate cyclones. To create the formation of temperate cyclones. Now, one needs to understand this thing, that the formation of the temperate cyclones can occur at any point of time. I mean, it can occur in the winters also, it can occur in the summers also. It is not necessary that you should have the particular time framework only. Okay, so the point is that why, what is the reason behind it? Because whenever the contrasting air masses will meet, it will create the formation of cyclones. And contrasting air masses can be present anytime, right? And contrasting air masses can be present at any point of time in a particular area, and there is no restriction with respect to whether it should be formed on the water bodies or the land. Therefore, the frequency of the formation of temperate cyclones is going to be much greater. But obviously, the intensity of this is going to be much more in the which season, which area? It is going to be much more in the winters. Why? Because the temperature difference between warm and the cold, the temperature difference between warm and the cold increases. And when the temperature difference between the warm and the cold fronts increases, it creates the greater velocity, and hence the intensity also increases. Now write down about the frequency part. Write down about the frequency part. Okay. Since the temperate cyclones are formed, since the temperate cyclones are formed, since the temperate cyclones are formed, write down, due to the front formation, comma, they are occurring throughout the year. They are occurring throughout the year. Full stop. Therefore, they are not confined to any particular season. Therefore, they are not confined to, they are not confined to any particular season. They are not confined to any particular season. Hence, the frequency of the formation of temperate cyclones is greater. Right on the last line. Therefore, the frequency is much more, but intensity of the cyclones, but the intensity of the cyclones is greater in the winters, as compared in the summers, as compared in the summers. And also if you see, I'm not denying that there is not going to be the precipitation. If you see this diagram, I'll also make you draw a very different diagram than what I have given to you initially. Now, where there is going to be the rising of the air, जहाँ जहाँ आपका air rise करेगा, वहाँ there will be the formation of the cumulonimbus clouds. And when the cumulonimbus clouds have been formed, the rainfall is definitely going to be there, right? So when the warm air will rise up, warm air rises up, and when the warm air rises up, there will be the precipitation. There is an unstable air. As the air is ascending, whenever the air will ascend, it will bring rainfall. Or the better word is precipitation, because you never know where it is being formed, right? So the formation of cumulonimbus clouds is also going to be there, and hence these are going to be the attributes, right? When the warm air rises, there will be formation of this. Draw it separately. I'll try to explain you how you have to understand how you to club this in the diagram which I've given you initially at the starting of the class. When we'll join both the diagrams, then you will understand the reason behind it, why we have drawn it separately. Basically, if you can understand from this, in this diagram, at a particular point, these warm fronts are there, right? And when these warm fronts are there, this one, air is rising up. And when the air is rising up, it will create this. When it rises up, it will create disturbance, it will create instability. You can also add the point, it will create instability in the area. It will create instability in the area, and therefore there will be rainfall which will be happening here. Please draw this diagram, it is important. And also write these characteristics. Online students, do you have any doubt? In the morning classes where I have discussed the answer writing session, I have discussed with you some sort of thunderstorm related question also. And that question I would give you in the assignment as well today, because it is related to this part only, right? Online students, have you drawn it? Please let me know in the comment section if you have drawn it. Yes, online students, everyone, please comment in the chat box. Please write it down quickly, everyone. Done. Okay. Now write down about the area coverage. Although we have discussed about that 1.6 million square kilometers is the area that is covered, but let's talk about it in detail. Write down area coverage. Write down the other heading, area coverage. Unmi, you were discussing, I think, in the answer writing session, right, in the morning, that how I have to frame my answers, right, in 7 to 8 minutes. So this is what I was trying to tell you. Whenever there is a question, you try to take 2 or 3 points, or maybe 4 or 5 maximum. That's all. Do not try to cover it up with so many points. Otherwise, what would happen? You will keep on answering only one section of the question, and then the other question you won't be able to answer. So when, if in case that your question is simple, then it's fine. Then you can take the 5 or 4 pointers in that. But if it is in the subsection is also included in that. For example, it is also asked about the challenges along with the definition or something where you have to comment in. So understand that whenever the question is divided into 2 parts, you have to also take care of the fact that whether are you fulfilling the demand of the question, are you answering both the parts of the question or not. You cannot just write these 5 points only delivering to one section of the question. That is what I was telling you. So here also in the temperate cyclones, when we are discussing about the area coverage, we are discussing about the instability, we are discussing about how it has been formed, all of which is discussed at the same point of time, right? So, and then we are dividing. I'm giving the headings, like I'm giving the shape, velocity, frequency, right? I'm giving the heading and then I'm making you write. These headings I was talking about. That when you're writing it, write it like point wise. Frequency given, shape given, velocity given. And now we are discussing about the area. And the first part that obviously should have been the part of it, which is how they have been formed. Formation of cyclones. That would have been the heading of it. Write down area coverage. Likhiye. Temperate cyclones develop over large area. Temperate cyclones develop over large area. Temperate cyclones develop over large area. They develop over large area, occupying 1500 or even sometimes more than, occupying 1500 or sometimes even more than 2000 kilometer of area. 2000 kilometer of an area. Full stop. In diameter. In diameter. Next, talk about what is the air pressure. Rather than second point, what is the air pressure? This one. Okay, write down. Air pressure. The pressure gradient in temperate cyclones is gentle. The I don't need to explain this point because I have given the definition, I have given the explanation how the pressure gradients work in this way. Write down. The pressure gradient in temperate cyclones are gentle as the isobars are widespread. As the isobars are widespread. As isobars are widespread. Full stop. Hence, the intensities of these cyclones are moderate, as intensity would be moderate. It is going to be only 10 to 15 MB. 10 to 15 MB. Write down next, direction of the winds or direction of the movement of the temperate cyclones. Write down about the direction. Next, we are going to write about direction. I'll give you a quite brief description of this temperate cyclones at the end, that how they have been formed, what are the structures. Again, we'll do the brief summary of it at the end of the class. Right, in 10 minutes, I'll give you the brief that how they are formed, what is the velocity, shape, etc. Just to give you a whole summary of the lecture. Right, write down. Since the temperate cyclones are developed in the mid-latitude areas, since they are developed in the mid-latitude areas where westerlies are prominent. Where westerlies are prominent. Now, which westerlies it is talking about? It is talking about these westerlies. Westerlies have been developed in which area? Subtropical high pressure to subpolar low pressure. When they are developed in subtropical high to subtropical low, what has been formed? Westerlies. Here the westerlies have been formed, right? How many of you have doubt in this? Westerlies are formed where? Just for the people who are having a doubt in it, I'm repeating it again. I have to draw the whole diagram. This is what I'm talking about. Equator. The next one is your subtropic. This is your subtropical high pressure. This is your subpolar low pressure. This is your polar high pressure. Now equatorial low pressure. Winds blow from high to low. When they are blowing from high to low, it is going to get diverted like this. Why? Because of the Coriolis force. And when it's going to get diverted because of the Coriolis force, definitely from high to low, that is the universal fact. The winds are always going to blow from high to low, and therefore it will get diverted. Reason being because of the Coriolis force. Whether they are going to get diverted with a high deflection or the low deflection depends upon how much is the intensity of the Coriolis force. Here at the equator, the intensity of the Coriolis force is going to be less. Reason? Because Coriolis force depends upon the rotational speed of the earth. Right? This is what we have discussed in our classes. Now high pressure, this is low. Again, it is going to get deflected like this. Since it is originating from the west, how do we define and give the definition? How do we say that these are the westerlies? Why I have taken the name westerlies only? Because they are originating from the west. Why these are known as trade winds or the easterlies? Because they are originating from the east. Therefore, these are easterlies and these are westerlies. This all has been discussed in detail in the class. This is just a recapitulation which I am doing to make you understand, to memorize you how we have discussed it and what are the factors. Just in case if you have forgotten this, right? We have already done it in detail. The entire classes I have given for the explanation of the easterlies, westerlies, and the polar easterlies. This has been done in detail. Now the fact is, if I'm talking about the mid latitudes, again and again I'm talking temperate cyclones are formed in the mid latitudes, 35 to 65. That means the impact of the westerlies is going to be great, right? Impact of westerlies is going to be great in this region. I should mark it with a different color. If you're talking about this area, this is the temperate. Can you see the westerlies? How are they? They are impacting. So when the westerlies are there, it will create the impact, right? These are the westerlies. It will create the impact, and there is going to be influence of this. Write down. Westerlies are prominent, and it's generating from west to east, and it is generating from and it is generating from west to east, and they are generating from west to east, full stop. Due to the Coriolis effect, the direction is not going to be straight. Due to the Coriolis effect, the direction is not going to be straight, not going to be straight. In fact, it will take a curved path. In fact, it will take a curved path due to Coriolis force. Due to Coriolis force. It will take a curved path due to Coriolis force effect. And how it would change? Understand. Very important point which is important to be noted here is your northern hemisphere, the deflection is going to be like this. So as I told you, northern hemisphere mein how the Coriolis force works. It works in a way that the deflection is going to be in the right direction, and in the southern hemisphere the deflection is going to be in the west direction. That is why if you see here in this diagram also, I have drawn the deflection like this, and this is your southern hemisphere. ये पूरा आपका southern hemisphere. क्या it will not impact the tropical cyclones? Definitely. अगर ये wind को affect कर रहा है तो tropical cyclones is a part of that. Tropical cyclones का direction भी change हो जाएगा northern और southern hemisphere में. I don't. Due to Coriolis force effects, the direction is not straight. It moves from west to east. It moves from west to east, but follow the path from southwest to northeast in northern hemisphere. From southwest, this is a southwest, ये direction, southwest to, this is a northeast, and this is a southwest. It is going to move like this. It moves from southwest to northeast in the northern hemisphere. Please underline northern hemisphere there so that you should not make mistake. Ishan, you're going on and off. Is there any problem in the network? Are you facing any problem in the network? Because I can see you a lot of times going on and off. Okay, just watch the recorded lectures, and if you have any doubt, please ask me tomorrow. I think the issue is at your end because here everything is fine. I hope your portal is fine. It's working okay. Good. All right. Now write down about the southern hemisphere. In the southern hemisphere, it is from northwest to southeast. Now, southern hemisphere में क्या होगा direction आपका change from northwest to southeast. In southern hemisphere. That's all about the basic description of the temperate cyclones. Now, in the last half an hour, I'm going to discuss about the world distribution of cyclones, how the cyclones are being distributed, and how many types of cyclones are we having. So before discussing any scholar, I have not introduced any scholars, and yes, you have to draw this important diagram. I should explain you this one. No, it's not working. Okay, these are the view. This is the bird view of the cyclones, how it would look like. The same thing. See here. Whatever I'm drawing here to the diagram, you can also see here. So this is a bird view, so you can only see this part, this much part. You will not be able to see this one, right? And if you see, what I've drawn is just similar to this. These are the warm fronts. It is a area of low pressure. This is a cold front. It will descend. Why it would descend? Cold air tends to descend. Cold air tends to descend. And this warm air rises up. Warm air rises up. And there would be a closed circles. Not entirely closed. Closed means that they will form like this. This is your high pressure and it will move towards. This is a warm air which is rising up. And this is nothing but inverted V or trough or depression. And here you will also have the precipitation. Why precipitation? Whenever the warm air rises up, it will create some kind of instability that is bound to come with it. Please draw this diagram as well if you have not drawn. And one more diagram I have to show, which is this one. Very prominent diagram. If you support your, see, whenever you are drawing any cold front which has been talked about or temperate cyclones, I'm not particularly discussing any topic here, but these diagrams are actually going to help you in understanding what is happening. Now, this is not the stage at which the temperate cyclones are being formed. This is not the first stage. The cyclones have been formed from here. And it will give you a view that how the advancement is going on through the stages. Talking about the first one, it would look like stationary. It is actually a kind of a stationary front. It is a type of a front which you call it as stationary. We had a discussion on this where the two air masses will look like they are standing against each other, just like at the frontier when the two forces are standing against each other, then they are not fighting, they're just standing there in order to protect their boundaries. They're standing at the frontier. Similarly, this is also reflecting that. This is just a metaphor I'm using. It is also reflecting that there nobody is getting into the boundaries of another. And then they are standing at the front, they're standing at their own location, but they're ready to come in the area, in the territory of each other, right? There could be an insurgence any point of time. Similarly, now warm air is there, so warm air is associated with rising up, right? Warm air tends to rise up, so here the warm air tends to go up. And hence you can see this part is getting upwards. The attribute, the characteristics of the cold air is to get down, it descends, so it is coming down, right? Again, the V type kind of shape has been not formed. It is again, it is in the formation, it's still developing, right? Now, talking about the third diagram, they have created a defined V kind of, inverted V kind of shape, wherein the warm fronts will go upwards, the warm air tends to go upwards, and it will create the precipitation here, and it will create the descending of the cold air. And then finally, if you see in this